Yeah.
Oh, welcome to Economics. I am Idris and I'll be taking you through econometrics for the meantime. So today we'll be discussing the multiple linear regression. Multiple linear regression. So in one of the videos we have made earlier, we discussed the simple linear regression, where we have just one independent variable and a dependent variable. For instance, in the consumption model, where we have the consumption depending on the income of the consumer, just like we have it here. That's the case of a simple linear regression. Then the demand model, quantity demanded, depends on the price of the commodity. It's also an example of the simple linear regression model. Then our U here is a random error term. So we will understand that the simple linear regression is often inadequate in practice. What do I mean by this? You agree with me that in reality, there are other factors that affect the quantity demanded. There are other factors that affect your consumption apart from the income and the price in the case of the quantity demanded. So there's a need for us to extend the discussion and include other variables in the model. So I'll be taking the quantity demand for example. The quantity demanded, let's say we're looking at the quantity demanded model is determined by the price of the commodity, the price of related commodities, then the income of the consumer. So this is the case of a multiple linear regression model. So this will help us explain the demand model better. Then, before we also proceed, it is very important I mention that there are three types of data one can work with in econometrics. You can work with the time series data, you can work with the cross sectional data, you can work with the panel data. Now, what's the difference between or among this data set? The time series data is a data set you collect at a particular point, like over time. Over time, you collect this data over time. Probably you're talking about the demand model. You collect the quantity demanded from, let's say, 1999 to 2020. That's the time series data. And how we know that, okay, we're working with a time series data is it comes with a subscript, that's T, just like the examples I've given here. So anytime you see this, alpha 1 plus alpha 2 pt plus ut, the subscript T is to indicate, okay, you are working with a time series data. Then the cross-sectional data is you are collecting data on a single variable, or let's say multiple variables, on different, like at a point in time on different, let's say Nigeria now, we're looking at quantity demanded in Nigeria or GDP in Nigeria. GDP in Nigeria, then Ghana, let's say Mali. These three countries, we're looking at, okay, what's the GDP in this country for the year 2020? That's at a particular point in time. So that's a cross-sectional data. And how you know this is, it comes with a subscript I. Pi plus ui. That's a cross-sectional data. Then for the panel data, it's a combination of the two. So we're looking at GDP in Nigeria, Ghana, Mali from 1999 to 2020. So in this case, you get GDP in Nigeria from 1999 to 2020. You get GDP in Ghana 1999 to 2020, you get GDP in Mali 1999 to 2020. Then it comes with the subscript IT. So we have now, I need to say that you don't have to mind this. I just use this as a notation just to explain to us. So I did that here. So this will come with IT, then IT. So those are the three kinds of data you can work with in econometrics. But for the sake of this class, I won't be indicating any subscript. We'll just be working straight because the purpose of this class is to derive the OLS estimators under the multiple linear regression model. So we're going to be working with an equation y plus beta 1 at plus beta 2 at x2 plus beta 3 at x3 plus u. Now, when we're working with beta 1 at, you're seeing the at here, that is to show that, okay, we have estimated this already. And the beta 1, beta 2, and beta 3 are actually the OLS estimators that we're about to derive the formula for them. So, how do we go about that? The first step is we make the error term, the u, the subject of the equation. Minus beta 2 at x2 x3. After doing this, you will take the sum of the error term. That means take the sum of both sides and square them. Summation ui square y minus beta 1 at you square them. Now the next step is to take the partial derivative of the sum of square here, the sum of the square of the residual with respect to each of the parameters. That's beta 1 at, beta 2 at, and beta 3 at. So we're going to be having partial this at over beta 2 and this is what we're going to be having here. So from here we can differentiate this partially with respect to beta 1 to get the first one to now give 2. Then we differentiate whatever we have inside this bracket, minus 1 with respect to beta 1. Then we have summation y minus beta 1 at minus beta 2 at x2 x3. Of course, that's going to be 2 minus 1 and that's 1, so we don't need to write that. So let's write this out. We have minus 2 summation y minus beta 1 at beta 2 at x2 minus beta 3 at x3. Then we know at our first derivative it's always equal to 0. That's the first order condition. So when we divide this by this, we are left with summation y minus beta 1 r minus beta 2 at x2 minus beta 3 at x3 equals to 0. That's for the first one. Then for the second one now, we are going to have to differentiate partially with respect to beta 2 at, and that will leave us with bring 2 forward, then differentiate whatever we have inside this. We are left with minus x2 we rewrite everything all squared. So we're going to have minus 2x2 summation y minus beta 1 r minus beta 2 at x2 minus beta 3 at x3 to be 2 minus 1. So we're left with 1. Then just like we did there, the first order condition is that this is equal to 0. So we have this to divide, and in this case here, so we have x2 summation y minus beta 1 r minus beta 2 at x2 minus beta 3 at x3 equals 0. Then for the third one, now give us, bring 2 forward as usual. Then we have to differentiate whatever we have in this with respect to x of beta 3. That will be minus x3 summation y minus beta 1r minus beta 2 at x2 x3. Then we have 2 minus 1, and that's one we don't need to write it. So we're left with minus 2x3 summation y minus beta 1r minus beta 2 at x2 equals 0. So we divide, we're left with x3 summation y minus beta 1r minus beta 2 at x2 equals 0. So those are the 3 equations. So we're going to write them out. We're going to write them out. First one, second one, then with x, this is x2 equals 0. Equals 0. So this is equation 1, equation 2, equation 3. So the 3 equations here can now be written. Remember what we did initially, we got that u at equals y minus beta 1 at minus beta 2 at x2 minus beta 3 at x3. That was where we started from initially, and this is basically what we're having here. So we can just say summation y minus beta 1 r minus beta 2 r x2 is the same thing as summation u r equals to 0. So I'm basically saying summation u at is equal to 0. That's the same thing as equation 1. Then in equation 2, saying summation u at x2 is equal to 0. Then in equation 3, now this has meaning, like it has meaning. You remember the assumptions of the OLS. So it said the mean value of the error term should be equal to 0. So this helps us to prove that, okay, the mean value or the average value of the error term is equal to 0. Then this too is to help us prove one of our assumptions that says that what the error term should be uncorrelated with the regressors. Error term and regressors. Error term is uncorrelated with the regressors. And what are the regressors in this case? The regressors are x2 and x3, while the dependent variable, the regressand, is y in this case. So we move on from here. We move on from here to from equation 1 now. It is very easy to derive the estimate of beta 1. Beta 1, then equation 2 and 3, we're going to be deriving the beta 2 and beta 3. So from equation 1, we have it that summation y minus beta 1 at minus beta 2 at x2 is equal to 0. So what do we do in this case? In this case, we expand, and it is important I say this now. To expand this summation, what you have to take note is that the variables will come after the summation sign, while constant in the equation will come before the summation sign. So in this case now, we have beta 1 as a parameter or constant coming before it. Then we have the summation sign, so it's just summation 1. Then in this case, it's coming before it, but because we have x2 here, the x2 has to come after it. So for beta 3, we do the same, equals to 0. Then theoretically, you will know that your summation 1 is equal to n. So how do we do that? We replace it by summation y equals beta 1 minus beta 1 times n minus beta 2 summation x2 minus beta 3 at summation x3 equals 0. Our aim is to make beta 1 the subject of the formula. So what do? We take it to the other side. We have summation y minus beta 2 at summation x2 minus beta 3 at summation x3 equals n beta 1 at. So divide both sides. Beta 1 equals summation y over n minus beta 2 at summation, let's get this off, minus beta 3 at summation x3 over n. So we move from there. You know from basic statistics that the mean of a variable y, which is y bar, is equal to the summation of y over n. The same thing for x bar, which is the mean of x, is equal to summation x over n. So in this case, we have x2, x3. So it's basically the same. We have x2 here. Then for x3, so we x2 summation x3 over n. So what do? Let's replace what we have in this. So we have beta 1 at equals y bar, which is the mean of y, minus beta 2 at, then summation x2 over n will give us x2 bar minus summation x3 over n will give us x3 bar. So this is the estimator for beta 1, and that is the formula. So to get beta 2 and beta 3, it will give us a little bit of problem. Why? Because we have beta 1 in this and beta 1 in this. So we're going to come up with an assumption. But before that, in estimation, what is reckoned with is regression, is the is the fact that we have our equation in the deviation form. What do I mean by deviation form? Deviation form is you use the small letters to represent your variables, and the small letters indicate that you had already subtracted your mean from the original value. So in this case, your y will be equal to y minus the mean of y. Your x2 will be x minus the mean of x2. Your x3 will be, this is x3 minus the mean of x3. So all these are already in the deviation form. So for the deviation form, what is important is you write it out in small letters. So what we have here, we can write it out in the deviation form as summation y in the small letter form, it's a 1r minus it's a 2r x2 small letter, it's a 3r x3 equals 0. Therefore, the second equation, y minus beta 1r minus beta 2r x2 minus beta 3r x3. Then we have x2 small letter x2 beta 3r x3 equals to 0. Now, why is this important? In estimation, when you are required to use this to solve your equation, to solve questions, you will have to use the formula in the deviation form to solve your question. So it is very important that we incorporate that right from now before we start deriving beta 2 and beta 3. But for beta 1, the formula remains the same this way. So beta 1 doesn't come in the deviation form. Only beta 2 and beta 3 comes in the deviation form. So it means that for your beta 1, you have to get the mean of y, the mean of x2, the mean of x3. That's after getting your beta 2 and your beta 3. And to do this now, we are going to be working with an assumption. The assumption that we are dealing with a regression line that passes through the origin. If it passes through the origin, that means our beta naught, which is our intercept, will be equal to 0. In that case, we're going to be having y equals beta 1 x1 plus beta 2 x2 plus u. So these are the estimated ones. So this is what we're going to be having. Beta naught will be equal to 0 because our regression line is passing through the intercept, it's passing through the origin. We have to make this assumption so that it will be very easy for us to derive the estimator of beta 2 and beta 3. And we move from there. So to do that now, we'll do the same thing. We'll make u at the subject of the equation, beta 1. Okay, let's call this beta 2 s2 minus beta 3 x3. Yes. So we take this sum of this, square it, x2 x3 square it. So it's basically the same step with what we have done earlier. So that will be giving us, we're going to be having summation y minus beta 2 x2 minus beta 3 x3 into x2 equals to 0. Then this will be giving us beta 2 x2 equals to 0. So we can expand this. We have summation x2y minus beta 2 summation x2 squared minus beta 3 summation x2 x3 equals 0. Then we have summation x3y, this is 2, minus beta 2, summation x2 x3 minus beta 3, summation x3 squared equals to 0. So these are the two we're going to be working with. So let's call this question 1, question 2. So let's make some stand on the right hand side and some on the left hand side. So we have this beta 2 summation x2 squared plus beta 3 equals x2y. Then we have this beta 2 summation x2 x3 plus beta 3 summation x3 squared equals summation x3y. So the next thing is to represent this in matrix form. So we're going to be using matrix to sort this out. So we represent this in matrix form. The coefficient of beta 2 and beta 3 in equation 1 and equation 2. So that will leave us with summation x2 squared, summation x2 x3, summation x2 x3, summation x3 squared, then beta 2 beta 3 equals summation x2y summation x3y. So what do? We use grammar show. First step is to get the general determinant. So we get the general determinant. So that will leave us with this. We multiply this. Minus this, multiply this. Squared. Now what's the next step? The next step is to get the determinant, to get the beta 2 at, and to do that we replace this with the first column. Replace the first column with this. So we're going to be having summation x2y, summation x3y, then summation x2 x3, summation x3 squared. So that will leave us with summation x2y, summation x3 squared minus summation x3y, summation x2 x3. So to get beta 2 now, beta 2 at is equal to, that's how we got up here, over the general determinant. So that's going to leave us with summation x2y, summation x3 squared minus summation x3y, x2 x3 over the general determinant we have here, summation x2 squared, summation x3 squared, and summation x2 x3 all squared. So our beta 2 equals summation x2y, summation x3 squared minus summation x3y, summation x2 x3 all over summation x2 squared, summation x3 squared minus summation x2 x3. So that's the estimator of beta 2, and that's how we derive it. For beta 3 now, all we have to do is to replace the second column with this. So say derive of beta 3 is summation x2 squared, summation x2 x3. Then we have summation x2y, summation x3y. So summation x2 squared multiplied by summation x3y minus summation x2y multiplied by summation x2 x3. Then to get beta 3, we have this dividing the general determinant. So beta 3 equals summation x2 squared summation x3y minus summation x2y summation x2 s3 over the general determinant, which is summation x2 squared summation x3 squared minus summation x2 x3 all squared. So that's how we derive for beta 3 also. So I'm going to write the three estimators out so that we can see it clearly. Beta 1 y bar minus beta 2 x2 bar minus beta 3 x3 bar. Then for beta 2 we have summation x2y summation x3 squared minus summation x3y summation x2 x3 all over. For beta 2 now, we have summation x2y summation x3 squared minus summation x3y summation x2 x3 all over summation x2 squared summation x3 squared minus summation x2 x3 all squared. So for beta 3 we have summation x2 all squared summation x3y minus summation x2y summation x2 x3 all over summation x2 squared summation x3 squared minus summation x2 x3 all squared. So these are the three estimators. So I would like to make a few comments on this. The first thing I would like to say is the two estimators, beta 2 and beta 3, their formulas are you can interchange them. What do I mean by that? You observe that x2, we have x2y here. Then in the case of this, we have x3y. In the case of this, we have x3 squared, we have s2 squared here. We have x3y here, we have x2y here. Why this? They are the same here, and the denominator are the same. So that's what you have to know. You have to know that denominators are the same, then you can interchange the variables. So once you know beta 2, you know beta 2 is summation x2y, summation x3 squared, then summation x3y. This and this, they are equal. Why denominators are the same? So to get beta 3, just change x3 to x2 here, change x2 to x3 here, then change s3 to s2 here, then you're good to go. Then another thing I would like to point out here is the fact that your beta 1, you reckon with the data like in the normal form, not in the deviation form. But for beta 2 and beta 3, for the purpose of estimation, you reckon with the deviation form, and that is why we have a formula in this format. So thank you very much. So in our next class, we'll be working with an example, a practical example to apply this and resolve a real question so that you understand how to apply this. But it is very important that we derive the estimators first, to put you through how to derive it, then we move on in the second class to talk about how we use this to solve questions. So I'll see you in the next class.
Please like and subscribe.